Gators. This is 6.3, Riemann sum, summation notation, and definite integral notation. Let's take a look at this graph f of x equals x squared, and let's approximate the area to the curve to start and move on to an exact area. So let's go ahead and first start with 4 subintervals. We're going to take the width of the interval, 3 minus 1 divided by 4, and the width of every interval is 1/2. So the area is approximately all of these rectangles added together. We're going to start with our first x-coordinate, which will be 1 plus 1/2 times k, which k will be 1. So this will be 1.5 will be my x-coordinate. I'm going to square it. That'll be my height, and times it by the width, which is 1/2. Then I'll move to the next x-coordinate, which k equal to 2. This will create the x-coordinate 2. 2 squared will be my height, times it by the width. And so we're going to add 4 rectangles together. What will it look like if I had 8 subintervals? Again, the width will be a lot less. It'll be 3 minus 1 divided by 8, which is 1/4. And our area will have 4 rectangles. So it's k equal to 1 to 8. We'll start at the number 1, but this time our x-coordinate doesn't move so far. It'll be 1 plus 1/4 k. We're going to square that. That'll be your height, and times it by the width. The width is smaller, which is 1/4. And if we add up all of these 8 rectangles, that will be our approximation. Let's go ahead and continue to approximate, but this time let's let the number of intervals be n. So it'll be 3 minus 1 divided by n, or 2 over n. So our area will be approximately going from 1 to n. We're having n rectangles. Again, we're going to go to the right. We'll have 1 plus, and our width is 2 over n times k, k being 1. That'll be your first x-coordinate. Square it to be your height, and then 2 over n will be your width. And we continue to let k equal to 2, 3, 4, so that we grab the rest of these x-coordinates into the formula and sum them up. So in order to move from an approximation to actual equal area, what we have to do is take this summation, and we have to take the limit as n approaches infinity. If we do that, we create more and more rectangles and better accuracy. So the definite integral is defined like this. The limit as n approaches infinity of the summation of the width times the height, and that's going to be this integral notation, this S shape, which stands for sum, from A to B, from the start to the finish of your height times your width. So it actually is the limit of all of these rectangles being added together. Let's talk about rewriting the definite integral here as a summation. So to do that, let's go ahead and again follow this format here. This will be the limit as n approaches infinity. We want to take a lot of rectangles as k equals 1 to n. And then let's go ahead and figure out the width. The width will be 6 minus 2 over n. That'll be our width. That's going to be this dx. And our height will be, what we want to do is we want to put it into this x, and we're going to start at the number 2, and we're going to add an increment n 4 over n, and times k, so that'll give us our little x-coordinate to the right. We're going to square it, and then we're going to subtract 3. And this will be our height, and this will be our width of each rectangle. What we're doing is we're putting this change going on into the x right here. Let's take a look at taking a limit and changing it into an integral. All right, so this is going to be an integral. What we need to know is where are our limits of integration. This is a dead giveaway. This is our b minus a, all right, and b minus a ends up being 6. So we could go from 0 to 6, and if we go from 0 to 6, that would 6b minus a, 6 minus 0 would be that. And then we know that this is end up going to be our width. So this is going to be our dx, and this is going to represent our height. So how will we write our height? So we'll write 4 plus, and then this is standing for our x coordinate, and our x coordinate here is going to be a 0, so it's 0 plus, and then this little increment, so this will be x, so it stands for x squared. So this x is changing all the time. From 0 to 6, we keep getting increments of it. Another way to look at this is to go from 4 to 10, because 4 to 10, b minus a, would also be equal to 6. If that's the case, then we're already starting at the number 4, so all we have to do is write x squared. Because we're starting at the number 4, our a is already the number 4, and then we're adding our little increments, and so the function is the squaring function. Our whole input value is being squared. Let's go ahead and take a look at this limit, and we're going to assume that the lower limit is 0, so that's going to help out. So this is going to be 0. And again, this 2 is a dead giveaway, b minus a. In order to get 2, and the lower limit is 0, then the top has to be 2. So we're going to get 2 minus 0, that'll be 2. This is our little delta x. These are our little widths. And so what will this be? Well, it looks like we have a 1 in the numerator, and it looks like we always have a 3 here, always plus 3 plus 3. And the only thing here is changing is our input value. And remember, our a is already 0, and we're inputting these varying numbers, which are what's changing is our x. So our integral looks like this. And the next one says the expression is a Riemann sum approximation. This is not the exact, but what is it approximating? Can we tell what it is? Well, hopefully you can tell that this right here is our width. So we know our width has to go, our b minus a has to be equal to 1, and 10 probably means 10 rectangles. So that's what that 10 is standing for. So this is our width, delta x, and we're going in an interval of 1, so we go 0 to 1. And it looks like the function is cosine, and our x value, our f of a plus b minus a over n times k. We know that b minus a is the a is 0, and we know we're constantly changing here, so that's just x here. And so where is the 10 in the integral? Well, the 10 really only refers to the 10 rectangles. If every one of these had been 50, we could have gone up to 50 over 50. It just means that it was being divided 50 ways instead of 10 ways. So the 10 doesn't have to be in the integral. It's just an indicator of your width. And this is the end of the screencast.